Hello and welcome to our YouTube channel Chemistry with Tanvi. In last lecture, we started the first chapter of 11th chemistry, some basic concepts of chemistry, in which already in previous lecture there we studied the physical properties of matter. First one is mass and weight, second is length, third is volume, fourth is density, and fifth one is temperature. In today's lecture, we start the new topic, that is laws of chemical combination. What is mean by chemical combination first? If one or two atoms or molecules combines to form another one, this is the chemical combination in which reactants and products are there. The elements combines with each other to form compounds. This process is governed by 5 basic laws discovered before the knowledge of molecular formula. So, the first law is the law of conservation of mass. This law is proposed by Antoine Lavoisier. Antoine Lavoisier in 1743. It is a French scientist, is often referred to as the father of modern chemistry. This is our father of modern chemistry. Father of modern chemistry. इन्हें हम केमिस्ट्री के मॉडर्न फादर भी कहते हैं. He carefully performed the many combustion experiments. He performed the number of combustion experiments. What is mean by combustion first? Burning of any substance in presence of air is known as combustion. Antoine Lavoisier performs the number of reactions which are the combustion reaction, namely burning of phosphorus and mercury, both in presence of air. Both resulted in increasing weight. If burning of phosphorus and mercury is there, then final result after burning is there is increasing weight after burning. After several experiments, he found that the weight gained by the phosphorus was exactly same. Weight gained by phosphorus is exactly same as the weight lost by the air. That means he observed that total mass of reactant equal to the total mass of product. यहाँ पे रिएक्टेंट कौन सा था? बर्निंग ऑफ फॉस्फोरस एंड Hg, that is mercury. And what is the product? Product is the weight lost by the air and the formation of ash of that metal. So he explained, or he proposed, the total mass of reactant is equal to the total mass of product. When hydrogen gas combines with oxygen to yield the water, when hydrogen gas combines with oxygen to forms the water. Here the mass of hydrogen and oxygen is consumed. This mass of hydrogen and oxygen is consumed and formation of product, that is water. This mass is gained. Thus, the law of conservation mass also states that mass can neither be created nor be destroyed. That means here अगर हमने जो भी रिएक्टेंट साइड में जितना भी मास हमने लिया था हाइड्रोजन और ऑक्सीजन का, उतना ही मास हमें प्रोडक्ट साइड में मिल जाएगा इन द फॉर्म ऑफ वाटर. ओके, this is the water preparation reaction. This is not actual combustion reaction, but it is an example. Here the mass of reactant side is equal to the mass of product side. That means this state also that mass can neither be created nor destroyed. Okay, that means again this mass statement is mass neither be created nor be destroyed in a chemical reaction or physical change. It remains constant. Here he performed the several experiments in combustion and a chemical reaction. Then next, the key points of this. Total mass of reactant is equal to the total mass of product. We already seen. Atoms are rearranged, not created or destroyed during reaction. That means at the time of reaction, there is not created or not be destroyed during the reaction. Third one is applies in closed system where no mass is exchanged with the surrounding. This is the reaction condition for this law. Then modern interpretation. Foundation of stoichiochemistry used to balance chemical equations and predict the reaction outcomes. Okay, the last one is significance. Ensure the accuracy in the chemical analysis and predictions, fundamental in understanding the chemical processes. This law is very useful for understanding what type of chemical process are going on while changing chemical changes or processes. Okay, this is the first law. The next law is law of definite proportion. French chemist Joseph Prost performed the experiment on 2 samples of cupric carbonate. He performs this on 2 samples of cupric carbonate. One sample was naturally in origin and other was a synthetic one. He found that he takes 2 samples of cupric carbonate. One is naturally origin, one is synthetic one. He found that the composition of elements present in that was same for both the sample as shown in below. That natural sample also contains percentage of copper is 51.35, same as for synthetic sample. Here the percentage of oxygen in natural as well as in synthetic is 38.91 and percentage of carbon in natural as well as in synthetic is 9.74. That means both the sample having same percentage. Then this lead Joseph Prost states that the law of definite proportion. A given compound always contains exactly the same proportion of elements by weight. That is also known as the law of constant combination. Here it states that a compound always contains exactly the same proportion of element by mass regardless the sample size or the source of the compound. That means अगर हम कोई भी कंपाउंड लेते हैं इन एग्जैक्टली सेम प्रोपोर्शन तो उसके एलिमेंट का वेट भी क्या रहता है, सेम रहता है उसमें. सो द की पॉइंट्स हियर, द एलिमेंट्स कंबाइन in fixed definite proportion to form the compounds. The ratio of masses of elements of a compound is constant. Important point. Example include water always having 2:1 ratio of hydrogen is to the oxygen by mass. Here water formulated as H2O. In water there is 2 moles of hydrogen and 1 mole of oxygen. So this is 2:1 ratio from hydrogens to oxygen. The next significance for this law of definite proportion or law of constant composition is fundamental principle is understanding the structure and behavior of chemical compounds, contributing the development of modern chemistry. It contributes to the behavior of chemical compound and modern chemistry. The next law is law of multiple proportion. Here this law is proposed by John Dalton in 18th century. It has been observed that 2 or more elements may form more than one compound. Law of multiple proportion summarizes many experiments such as compounds. That means when 2 elements A and B forms more than one compounds, the masses of element B that combines with A given a mass of A are always in the ratio of small whole numbers. For example, if formation of water is given as hydrogen plus oxygen gives rise to water. Here the molecular formula of hydrogen is H. It is taken as 2 gram because of here H2O. So 2 gram is taken. Oxygen molecular weight is 16 gram and water is H2O, that is 18 gram. So there is formation of hydrogen plus oxygen is given rise to water molecule, that is 2 gram plus 16 gram is equal to 18. That means masses are same. But if we again add the hydrogen and oxygen in different way, then if we take the hydrogen as 2 gram, oxygen as 32 gram, then the formation of 34 gram, and it is not water, it is a hydrogen peroxide that is formulated as H2O2. Here it is found that the 2 masses of oxygen, that is 16 gram and 32 gram, which combines with a fixed mass of hydrogen, that is 2 gram, are in the ratio of small whole numbers, that is 16:32 or 1:2. Okay, understand? very easy. That means अगर हमने कोई भी 2 एलिमेंट्स लिए और उनके एक के प्रोपोर्शन हमने फिक्स रखा और दूसरे का प्रोपोर्शन हमने चेंज किया, तो फॉर्म होने वाले कंपाउंड्स भी डिफरेंट होते हैं. ओके, दिस इज द लॉ ऑफ मल्टीपल प्रोपोर्शन एंड उसका प्रोपोर्शन हमें लिखना जरूरी है. दिस आर 16 फ्रॉम रिएक्टेंट साइड, दिस फ्रॉम प्रोडक्ट साइड. is of oxygen in a water formation and 32 is the proportion of oxygen in a H2O2 formation. Okay, that is 1:2. If we taking another example as this law, if nitrogen and oxygen combines to form the nitric oxide, if we take 14 gram of nitrogen, 16 gram of oxygen, then the formation of 30 gram of nitric oxide. Okay, and if we taking nitrogen plus oxygen in the 14 gram and 32 gram proportion, then the nitrogen dioxide is formed, having 46 gram. That means here the proportion of oxygen to nitric oxide is to nitrogen dioxide is 16 is to again 32. That means 1 is to 2. Okay, this is the second example for law of multiple proportion. Then our fourth law is, that is Gay-Lussac's law for gaseous volume. This law is put forward by scientist Gay-Lussac in 1808. The law states that when the gases combines or produced in a chemical reaction, they do so in a simple ratio by the volume, provided all the gases are at the same temperature and the pressure. This is the statement for this law. That means अगर हमने कोई भी दो गैसेस सब्सटेंस लिए तो फॉर्म होने वाला प्रोडक्ट भी गैसेस फॉर्म में रहेगा और उसका वॉल्यूम जो होगा वो वॉल्यूम का रेशियो जो है प्रोवाइडेड बाय ऑल गैसेस आर एट ऑल सेम टेम्परेचर एंड प्रेशर को सेम रहेगा. फॉर दिस फर्स्ट example, under the same condition of temperature and pressure, 100 ml of hydrogen combines with 50 ml of oxygen to give the 100 ml of water vapor. This 100 ml of hydrogen gas plus 50 ml of oxygen gas gives rise to water vapor 100 ml. That means the quantity taken as 2 volume is to 1 volume is given as 2 volume. That means the volume of hydrogen gas and oxygen gas which combines together, that is 100 ml and 50 ml, producing 2 volumes of water vapor which amounts to 100 ml, bears a simple ratio 2 is to 1 is to 2. Okay, let us see the another example. Under the same condition of temperature and pressure, 1 liter of nitrogen gas 1 liter, that means volume 1 volume, combines with hydrogen gas, that is 3 liter, that means 3 volume, to form ammonia NH3, ammonia gas having 2 liter of gas, that is 2 volume. So this ratio is, thus the volume of nitrogen gas and the hydrogen gas which combines together, that is 1 liter and 3 liter combines together, a volume of 3 liter of ammonia is produced. That is the simple ratio of 1 is to 3 is to 2. Okay, this is the example, another example for Gay-Lussac's law. Then the last law is Avogadro's law. This is very simple law proposed by Avogadro in 1811. See, Avogadro proposed that the equal volume of all gases at the same temperature and pressure contains equal number of molecules. Very simple law. If we consider the reaction of hydrogen and oxygen to produce water vapor, we know that if hydrogen and oxygen is produced to form the water, H2O, half of O2, twice of H2. Consider hydrogen gas taking as 100 ml plus oxygen gas taking as 50 ml gives rise to water vapor, that is of 100 ml. That means 2 volume is to 1 volume is to 2 volume. This is Gay-Lussac's law. That means 2n molecules, here 1 molecule of oxygen and here again 2 volume, that means 2n molecules of water is formed, water vapor is formed. According to the Avogadro law, this 2n, that means the two molecules, one volume, that means the one molecule, and two molecules, that means the two volume. Okay, that means these two volumes of hydrogen combines with one volume of oxygen to give the two volume of water vapor without leaving any unreacted oxygen. According to the Avogadro law, if one volume contains n mole, one volume is equal to n mole, n molecules. Then 2n molecules means 2 volume. Therefore, 2 molecules of hydrogen gas combines with 1 molecule of oxygen to give the 2 molecules of water vapor. Avogadro could explain the above result by considering the molecules to be polyatomic. This law is stated for the polyatomic molecules. If hydrogen and oxygen were considered as diatomic, as recognized now, then the above results are easily understandable. Okay, this is the best diagrammatic representation of the water vapor. First, one volume of hydrogen gas combines with one volume of hydrogen gas, that means both combines to form 2 volume, and here that means 2n molecules. Here 1 volume of oxygen, that means 1n or n of oxygen, here 2n of hydrogen to form the 2 volume of water molecule, that means 2n of water vapor or water molecule, according to the Avogadro's Gay-Lussac's law and Avogadro's law. Okay, thank you for watching. If you find this video helpful and found it helpful, please give it thumbs up, leave a comment and subscribe too. Don't forget the hit bell icon to stay updated over a latest video. See you next time. Bye bye.